Okay, we should be back. It looked like by default this thing was trying to downscale to a resolution that was pretty ordinary. So I've now kicked it off again. And hopefully now it will look a lot better. I'm going to fire it up on my laptop at the same time so that I can see. That looks a little bit better. Much better? Yeah, awesome. Okay, I'm really sorry about that, guys. Thank you for the call out. Who is it that mentioned that? Streams Atwolf. Thank you, Atwolf. That's exactly the kind of thing that I need to know to make sure that things are behaving themselves. So thank you very much for that. Tea is so good. Okay, so back to what we were talking about. Yeah, so what I'm going to do is look at what Meterp looks like when it's running straight off an exe, and then possibly how it injects itself into remote processes. So that's basically what this is going to be all about. Now, I've done a little bit of pre-work here before the stream, and that is I've created a Meterpreter payload, or I'll recreate it now. And I'll have a listener set up. So this is just going to be a standard 32-bit Meterpreter payload that I'm going to run to get a shell on, and I've got MSF console ready to go, so I've got a listener. So this means we'll have a Meterpreter agent running, and we'll be able to interact with it from Metasploit. And that's what we're going to use to experiment this thing. Okay, so we next need to figure out what this thing is. Now, what parameters does this have? Okay, so it doesn't have any parameters. So I guess what I can do is grab this. Hey, check it out. My little notification thing just worked. Matthew Herbs is now following. Matty Herbs, a very long-term developer friend of mine and a wonderful human being. Please welcome Matty. He is a champion. Whoa, the pop-ups work. Yeah, fancy. Yeah, I had a lot of fun playing with that a little bit earlier. So, yeah, happy with that. Okay, so what we need, we're going to need a PowerShell prompt. Probably I don't know whether I need to run this as admin, but I'll do it anyway. Sad I can't test the bits. Yeah, you can't test the bits because I'm not a Twitch affiliate. So that's something that I'm going to aim to resolve. I'm going to just stick to Twitch, and I'm going to try and stream to the point where I can get an affiliate, and then we can start having a bit more fun with that sort of stuff. Okay, so what I'm going to do is I'm just going to pipe this in system.net.webclient.download string. I'm just going to download that and put it into the interpreter. Get injected thread. Okay, so I run get injected thread and nothing comes out. Which is not surprising. I'd be probably a little bit concerned if something did actually come out as a result of that being running, but hey, Rasta, good morning to you, sir. Thank you for joining in. So what else we got going on? Right, so with that in mind, let's just fire off this payload. Where was it? Network, shared folders, stream, payload. I'll just drop this on desktop. I've disabled Windows Defender, just so you know, because it's just going to interfere with stuff, and we're really not here to bypass Windows Defender's antivirus. What I want to show you is sort of thread specific. Okay, so I'm just going to run this, and let's have a look. Okay, so yep, we have boarded the fail train. Okay, so as you can see, we're running a fairly up-to-date build of Windows 10. I think it's the latest version. I don't know whether choo-choo, exactly. Hey, Ozjock, thanks for coming in, dude. All right, so what happens now? So I've only run the payload. Now, based on the description that we've got in Jared's code over here, open process virtual out write process memory. See, we haven't done any of these things yet. So what I'm thinking is, because we haven't actually done any virtual alloc of bits and pieces, that nothing's really going to fire here. I mean, in the back of my head, I know that actually there's two things that have happened. Reflective DLL injection has happened twice. Okay, so once the payload ran, sorry, three times. So metserve will kick off first. Then there's standard API and then the priv extensions. So there's 3 extensions that have loaded. The question is, I mean, has a thread actually kicked off as a result of that? I don't think so. So let's just see. If we run get injected thread again, it'll be interesting to see if it comes up with anything. Okay, now that's interesting, isn't it? We are effectively still running single threaded, so maybe it's not that crazy because the exe that kicked off, it didn't have any injected threads, it just had the main thread that was kicked off before. So what we should probably do then is, if we duck over here, now we want to run something kind of behind the scenes in Meterp that will cause it to kick off a separate thread. Any ideas? I've got one. Any Meterpreter users out there have an idea of a command that we can use to kick off a thread that's built in? Shell? Migrate to another process. I'm going to do migration in just a minute, Atwolf. Shell, let's see what shell does. Get system. I knew the get system. Yeah, hate you guys. You know what I need to do? I need to wire something into this tool that dings every time a get system happens and then kick bans the person that says it. Multi would never be allowed back in. All right, let's type shell and see what happens. Let's jump into a shell. I would assume that there's another thread running now. So get injected thread. What do we? Hey, there we go. There it is. So process name, payload, path. So it's definitely our executable. There's no path mismatch. Thread start time, memory state, memory type, base priority. Okay, so that's really interesting. That's really interesting. So we have an injected thread, clearly. Now let's just exit out of that and see what happens when we run it again. All right, the thread is gone. Interesting. Nice job, Jared. That's pretty interesting stuff. Now, to fully understand what's going on here, I'm going to dive into Jared's code a little bit, but I think based on the reading that I've done, I think I might know what it is that's causing the problem. Ah, here we go. Multi's trying to use bloody filter bypasses already. What a jerk. Someone should ban that guy. He's awful. Okay, so the thing that stands out for me, I had to look through this code earlier on. So let's have a look at what this is doing, right? So it's looping through every process. So get process would clearly return. Let's just follow this through. Get process. Whoa. So that gets a full list of processes. So for each process, if the process IDs are not 0 and 4, well, that's clearly a good idea because we're not going to be able to do anything with 0 or 4, given that they are very special. Thread ID. Okay, so if we have a verbose, right verbose. I don't know how to turn verbose on. I'm sure there's probably some PowerShell related thing. What do we do? So thread ID. So it's iterating through the threads in the process. And then it's opening the thread. And then what is it doing? NT query information thread. Thread handle thread. So it's getting thread related information. And it's using, here we got base address. Getting a handle to the process as well as the thread. Okay, so if it can get thread information and process information, then what is it doing? Memory basic info, virtual query EX. So it's querying, for those people who don't know what virtual query does, virtual query EX. So virtual query retrieves information about a range of pages within the virtual address space of a specified process. So what this is doing by the looks is it opens the thread and the process, and then it queries within that process the base address of the thread. Right? NT query information thread. Now I'm not familiar with this. By the looks of it, it just returns Kernel entry. NT query information thread. Give it a thread handle and you get all of this other stuff out. Okay. So what it returns would be a thread info class. If this parameter is thread alias pending, thread info class enumeration function determines whether the thread is. Okay, so that's not what we're looking for. A pointer to a buffer which the function writes to request the info. Okay. So this is probably... Yeah, okay. So this is just effectively looking for information with regards to the thread, but there's one thing that's interesting here. So NT query information thread, is that something that's baked into PowerShell by default? NT... No. So what is this? Retrieves information about the specified thread. Is that something, I wonder, that's part of this script? Query information. Okay. Here we go. Function definitions. Right, okay. So there's a wrapper around it baked into the code. It seems it would check where the thread is being executed from. That address is outside the addresses. We use actual code written to memory. The binary will... Yeah, that's basically what I'm thinking. Serializing. I think because there's a flag that goes on certain areas of memory that are applied only when that region of memory was mapped from the original PE image that was loaded. So the .exe that kicked off, or a DLL that was, a DLL that was loaded with load library from disk. So by the looks of it, this here says it retrieves information about the specified thread. Parameter. Okay, so you just have to give it a thread handle. And goes away and grabs the information. This is interesting. Aha. This makes a lot more sense now, I think. So, system runtime, interrupt services, Marshall, Alex. So it's what we're doing is we're creating a buffer that is the size of a pointer of the current architecture. It's calling the underlying query information thread, passing in 9 as the second parameter, which I would assume is saying, give me the base information, give me the base address of the thread. So then what it does is it returns read int pointer buff, or writes it out. Okay, so yeah, base address equals this. Yep. Righto, so thread info class, we should probably go and find out what these things are. Here we go. Number 9. Here we go, this one here. Thread query set win32 start address. So that's returning the address that the thread was actually started in. 9 gives you the start address. Yep, that's what we've just proven. But I just thought I'd double check the documentation rather than making any assumptions. So that looks to be the go. You know, if I was going to be a really picky developer, I would argue that this NT query information thread is actually poorly named. Jared, we're going to have a discussion about that. That should be NT query information thread base or something to imply that that's what you're going to get out of it. Anyway, let's move on. I could sit here and pick holes in everyone's code. It doesn't mean that I'm good at what I do. My code's just as shit, if not worse. Okay, so we've established that we are getting the base address and then we're doing a virtual query of that base address in the process. And what is it doing? We're getting allocated memory protection. Mem protection, state, and type. Okay, so this is where it's going to start getting interesting. Memory state. So if the memory state isn't committed and the memory type is not mem image. Now this is the key bit here, I believe. So as you can see, this if statement here basically is completely bypassed and is false. So if memimage is set, then this whole process is ignored. Now, this is something that, again, if you've done any Win32 in the past, you'll know that memimage is a thing. And you'll see, hang on, where is it? Okay, so the types. You've got 3 types: memimage, memmapped, and memprivate. Okay, so, hey, look, it's there you go, mate. Thanks for joining in. So memimage flag says that the memory pages within the given region are mapped into the view of an image section. So that would mean a PE image. And so that PE image's section resides in that area of memory. So what this is effectively saying is that if your thread is created with a base address that points to... Lazy is now... These little notifications are kind of cool, aren't they? Thanks for following, guys. So what this is saying is that if we can kick off all of our threads with a base address that points to something that we know was mapped into memory via an image, we should be able to bypass exactly this. If you reuse code caves, so the binary... Yeah, you see, now, this is what I was thinking, serializing. I reckon there's a number of ways that you could get past this. Bits notifications can be more fun. Donation wars. So what I was thinking to begin with was like, okay, what if we pointed it to an area of memory that we knew had a ret structure, a ret call, just a ret call. And then what we need to do is create the thread suspended. And once it's suspended, we could get the thread context and set the content of the stack to an address that we control, and then just point and just let the thread resume, and then the ret would just basically bump the code straight back to us. But then I got thinking about that even more, and I don't even know whether we need to go that far. Yeah, that's exactly it. So what we just need to kick it off in a spot that makes everything think it's okay. So I think what we need to do is we need to do some testing, because I think it depends on when let's say the thread information context is created, because if it's created at the point like all prior to the thread actually spinning up, then there's another way that we could do this really, really easily without having to worry about it's like searching areas of memory or writing stuff into code caves, or just having some kind of trampoline like a red instruction that pops a hard-coded address of ours off the stack. We could be even dumber. Now, based on the way that I think the threading works, because you can create threads suspended, right? You can create threads suspended. If that's the case, then you would assume that the thread context already exists, right? So my thinking is what we need to do is we need to, in Meterpreter, this is what I'm about to suggest is a lot easier, because we basically have a single point of entry for creation of threads, or at least it should be used all the way through all of the code. It might not be the case, but what I'm going to do is I'm going to focus on the area of code that creates threads within the Meterpreter context, and then what we'll do is we'll look at how we might do this from the perspective of like cross-process injection, which clearly is going to be a little bit more tricky. Is everyone following? Does anyone have any questions? No? I'll show you, while I'm waiting for you guys to ask questions, check this out. It's my, I've got a Stream Deck too, which is kind of cool. And it's got all these funky buttons and whatnot on it. So now, for example, I can press the OPSEC button, which means I hide everything but the camera and the chat. And then I do something which could be OPSEC unsafe. And then I can go back to the original scene. All at the click of a button. It's fantastic. Who we got? Serializing Slickers. Hello. Welcome to the stream. Thank you. And Gmon XYZ. Lovely to have you all. Thank you very much for joining in and having a bit of fun with us. Make sure you have tea T is really important. It can be black if you like, but no infusions. Infusions are just right out. So, oh, we got another pop-up coming. Someone's just followed. Gmon XYZ has followed. Thank you, sir. Ooh, coffee. Yeah, well, it depends on the time of day. Lazy, I would agree with that. That coffee is indeed a win. Just made some coffee. Coffee is perfectly fine. Hey, Vendetta, thanks for coming in, buddy. Okay, so here's what I'm thinking, right? Let me show you what I'm getting at. First of all, I'm going to minimize this. We'll leave this running here, and we'll even actually we'll terminate Meterpreter for now, and we'll just leave the listener running. Now I'm going to open up Viz Studio, and we are going to open the Meterpreter source code, which takes a little bit of time to run inside of VM. You can never go too hard on T, Zorcat. Never too hard. Depends, I guess, on how caffeinated it is. Now, so have a look at this. We've got a function in Meterpreter called createThread. Okay, so where are we? Base dispatch. I should probably do, where is it? You can see there's some thread creation stuff that goes on with Mimikatz as well. But the one that I'm really looking for is mod inject. Oh no, it's not called createThread, it's called thread create. There we go. Thread create. So we can go to the definition of this. So behind the scenes, I would like pretty much all of these bits of code to use the thread create code. Now it's a little bit messy, but it is what it is, right? Good morning, CLS Sesco. Greetings to you from Australia. Thanks for joining in. Mugu, what are the changes you do to Meterpreter before engagements? Share key points or custom payload? Oh, that's probably a topic for another stream, to be honest. We should sit down and have an AMA or something with Meterpreter related shenanigans. I'm happy to share some of the things that I muck around with when I'm using Meterpreter on engagements, which I do, but not all the time. But yeah, it's a complex topic. There's quite a bit that we can cover for that too. I've had another follower. Who's that? 7sharp9. Hey, mate, how you going? Another very old developer friend of mine and a functional programming zealot alongside me. 7sharp9. Haven't seen him for a long time, but he's a top lad. If you're a fan of F#, you should follow this guy. He knows his stuff. So thanks for chiming in, mate. That's awesome. Okay, so let's go back to here. So what we're going to do is, you see here we've got this wrapper called thread create, which kind of puts some Meterpreter specific context around the thread. And I've got another follower, Sneaky Code. Thanks for following. I'm going to stop saying thanks for following because that seems to happen on a lot of streams and it's bizarre. So the aim here is to be able to wrap some management context around threading inside the Meterpreter engine. And to do that, we do a bunch of other magic. Now, you'll notice here that when we call create thread, we have this thread preamble. And we always create it suspended. So thread preamble, as you can see, is a little wrapper around the invocation of the payload or the thread entry point that we're going to be using. Okay, so this is important. Now, so what we do is we pass in, when we call thread create, we pass in a function and we say this is the parameter, this is the function that we want invoked. And one of the issues that we have is, like, inside Windows, every single thread can have its own error reporting mechanism, and the process can have its own as well. So I'm sure everyone here has seen a case where a process has crashed or a thread has died, and you get one of those pop-ups, one of those message boxes that pops up and says, you know, there was an assertion failure here, or there was a nullity reference, or something similar. So what we're doing is we're actually trying to hook the thread when it starts up and we're just specifically stopping that thread from reporting the error in that way. And the reason we're doing that is because if for some reason during the processing of the thread context through the functionality that we're looking to invoke on that thread, there is something that causes the thread to die, if we happen to be in like a user land process, like explorer.exe or something like that, then the user who may be interacting with the desktop at that time is going to get that pop-up saying something went wrong. And obviously we don't want them to see that. Now, of course, threads never crash in Meterpreter. They're all perfect. So we technically don't need this. But yeah, anyway, we'll just use that as a segue to talk about something a little bit more interesting. So we create the thread suspended, okay? Now, if we look at all the cases where thread is created, for example, let's have a look in standard API. Righto, so here's a typical call. We want to do this desktop screenshot thread. So it's creating a thread to do screenshots, okay? And it passes in a pointer to this function with a bunch of other contexts that it may or may not use, right? And every single thread that comes back out is suspended, right? So straight away there is a thread run call. Okay, does that make sense? Hello, Snoxes. Thank you for joining in. So what we're doing, let me go back over here. And you'll notice that what we do is we pass in this thread preamble and we give it the thread context for all of the, so that we can pass in the thread related information to when the thread actually starts. Now inside the thread preamble, we call this disable thread error reporting function, which is just a wrapper that grabs access to kernel 32, pulls out a reference to set thread error mode, and we basically invoke that to say don't show any critical errors. Okay, so that basically means if the thread dies, we're not going to inform the user. That's basically what that is. And then when that's done, you can see straight away we just invoke the function that was given to us with the thread context. Okay, so that's all that's doing, nothing particularly special. Okay, but thread run is invoked pretty much immediately when the thread is created. Now, here's a question. So when we type shell, do we actually call this thread create? I would assume that we do. Let's just have a quick gander. So standard API, where would we find this? This is the key question. Now we know that it's going to be, it's a standard API function. So we should see it somewhere in standard API. Let's just have a look in here. Image, memory, process. Here we go. Process execute. So here's the thing. That's right. So when we call shell, we do two things. We execute a process, and we kind of tie the output of that process to a channel. And the channel's running behind the scenes, and it's basically shuffling the output of the process coming out of standard out down the neck of a TLV packet back out to Metasploit. And Metasploit kind of does the reverse. It sends the commands in. The channel thread will read that information off the TLV packet, a wire, and then basically from there, it bubbles that down to standard in for the process so that you can get that interaction. I'm trending number 3 in science and technology. Really? Wow, there's 52 people watching. According to my new stream deck, there is 52 people. That's amazing. 58 people. Wow. Wow, this is epic. Thanks for joining in, everyone. I'm super stoked that you guys are here. Anyway, so you can see we've got those two parts, right? We have the process creation one, and we have the thread that manages the interaction of that process with Metasploit, okay? So clearly what we need to do is go and have a look at the channel related stuff. So question is channel part of MetServe or is it part of standard API? It might actually be part of standard API. Is it channel create? So channel's like an abstract term inside well, it's not an abstract term. It's a term that basically means a means of communication with Metasploit through to Meterpreter doing a thing within the current context of the entire session. So once we've established a Meterpreter session, there's a lot of traffic that goes back and forth, but we might want to be able to just sort of send bits of information back and forth between two arbitrary managed endpoints along the same communications channel, and that's basically what a channel happens to be. Okay, so let's just go and dig up. See, we've got these. I'm cheating because I'm just grepping the source code for these functions, but we can see there's a channel create stream, channel create datagram, etc. And there's going to be a bunch of cases where a channel is actually created. So let's just have a quick look down here. Here we go. Here we go. This looks like it could be a goer. So when we create a process, there you go, process execute. Depending on the parameters that are passed in when the process is executed, which we can actually have a look on the Metasploit side in a second to make that clear. But we can see if we are channelizing the execution of this process, then we need to go and create a channel in the particular pool. Yeah, no pressure, Rasta. Hello, Huerg. How are you going? Thanks for joining into the stream. And Slickers, are you going to B-Sides Canberra? Nah, mate, I'm afraid I'm not going to be able to make it to B-Sides this year. Right, so we're creating the channel as soon as we've created the process that we're going to bind it to. Okay, so channel create. Now, behind the scenes, I would assume that when you create a channel in this regard, there's going to be a thread that's associated with it. Now, I'm not seeing anything here that references a new thread. Open thread. So what's going on here? If there's an impersonated token, okay, so that's to do with impersonation. I'm not worried about that. What we are interested in looking at is set type. Let's go and have a look at the contents of create channel pool, which behind the scenes again uses channel create. We create some channel context, channel set buffer.io handler, channel add list entry. What is this doing? Okay, so that's just doing channel related stuff for maintaining context. Channel add list entry. Okay, so there is clearly a list of channels that are being processed. Okay, so maybe it's the scheduler. There'd be a scheduler thread running. Yeah, because every single channel that you create gets added to a list of channels, as we can see here. And then what we end up doing is having something call back on threads that are running when events happen on those channels. So we need to figure out where the thread that's created that manages this channel happens, because somewhere in here there's going to be some kind of processing that's happening asynchronously on a separate thread. So we just need to figure out where that is. It's been a while since I've looked in this code, so packet completion routine. Channel completion routine handler. Okay. I think I know where we're going now. Let's just see. Whoops, that's not a good thing to search for. What I'm looking for is for there's going to be a scheduler somewhere. I just got to try and remember where it's actually used. There, here we go. Man, this is bringing back some pretty horrific memories. There was a period of time in the early days of working on Meterpreter where I really had to dive deep into some of this scheduler and channel management code, and it really did my head in. Snoxes, today's topic is what we're trying to do, and I'll just do a quick recap for all of the people who are currently watching, and I'll make it very brief so that the people who have been watching the whole time don't get bored. If we have a Meterpreter payload running, and we're interacting with it, and let's say we call shell, then we have the means through tools such as Jared Atkinson's get injected thread to determine whether or not a process has an injected thread in it. Now this is bad because it's detectable. And so what we're trying to do is modify the code so that this get injected thread no longer comes back with a thread that's been injected, just for us to be a little bit more quiet from an EDR standpoint. Mr. Flint. Hey bro, this might be crazy, but do you code like you can code a GTA server? It is a crazy question. Some people know that I have worked as a developer in the past. That thankfully is in the past, at least from a building code for other people's perspective. But you know, building a GTA server, for example, that's a significant amount of work. And well beyond the scope of this stream, I'm afraid. But I'd be happy to have a discussion with people about it down the track if everyone was interested. Tea is so good. Okay, so there's the context. We're just trying to figure out... Ooh, here we go. We're just trying to figure out where these threads are created from a scheduling standpoint to make sure that we hook at the right point, so that we know that when we invoke a thread that we can say, hey, go and point it to a different location in an effort to bypass this get injected thread functionality. So scheduler initialize. So you can see, we do have a scheduler, and the scheduler should have its own thread. Here we go, scheduler waitable thread. The scheduler's waitable thread. Each scheduled item will have its own thread, which waits for either data to process or the thread to signal to terminate. Okay. So, this is no doubt being used. Here we go. There's the thread create call. Check it out. Thread create. So it is calling thread create and it's passing in this scheduler wait thread. This is fantastic. Someone did say hook, but I don't think we're going to hook anything. I'm not going to do any hooking here, I'm afraid. OJ is a future man based upon his virtual box's time. That's true. 9:49. Yeah, it looks like my my VMware VM is actually in Sydney while I'm currently sitting in Brisbane. Technology is wonderful, isn't it? Okay. Sure you are. Okay, so this is exciting because I'm 100% certain that this insert waitable is used when we're creating channels. There's no doubt about that. In fact, let's see if we can find it in here. It would be as part of this queuing, I would assume. Channel open. Try to open a channel with the remote endpoint. Blah blah blah. Duplicate completion routine. Pack transmit. So this isn't the area we're looking for. Where are we? So I'm going to assume that this is actually hooked in. So I'm just trying to get my head around the structure of this code before I talk about it again. Otherwise, I'm just kind of babbling without really knowing. So let's just see. Set buffered IO handler, channel add list entry. Yeah, so that's just adding it to the channel list. Channel create. Aurora Borealis. This time of year, this time of day. I know. I should put some kind of script in this thing that changes my backgrounds all the time, so that I kind of look like I'm gallivanting around the world. Maybe that's for another day. All right, let's just go back to this creation of threads for a minute, because I think this is where we should focus, because we're going to have plenty of time to look elsewhere. We've got another follower. Thank you everyone for following. I very much appreciate it. Okay, so let's close all this stuff off. Thread create. Now I'm pretty sure it was a... There I am trying to narrow down my search. Didn't work for me. Okay. Oops, wrong button. 12. Okay, so what I want to do here is before returning this thread, I want to play with this a little bit. Okay, so we know that the thread is suspended because every thread is being created suspended, right? So if we've got, is it get thread information or is it information thread? Get thread context. Yeah, right. So, pretty sure this is it. So this thread. So if that succeeds, we're basically saying we want to grab some context out of the thread, right? That Vimeo link in your info goes vimeo.com instead of vimeo.com. Just want to make... Ah, thank you. Nice fat finger. I appreciate that, Minotot W. I will go and fix that after the stream. Thank you very much. I appreciate that. So let's just go and look at the documentation. Get thread context. Okay. So, appointed to a context structure. Really? Was it as simple as that? So we need a context structure. We'll initialize this to 0. And then we'll pass that in here. Now, if it doesn't work, I'm just going to let things continue. But if it does work, we need to know, what do we got here? There looks like there's a bunch of... Ah, okay. So we're going to have some platform-specific things to worry about here, aren't we? So the context could actually be... It could be 64-bit, it could be 32-bit, right? Is there like a context 64 as well? Context. Let's focus for now on 32-bit. Okay. So we know here, for example, that there is a EIP. So that's the instruction pointer for where the thread is going to continue executing from, right? So, are you thinking what I'm thinking, guys? And gals? And whoever else is watching? So what I'm thinking is this. We've already spun up the thread at this point, which means the thread context has already been created. So instead of pointing at our thread preamble, because thread preamble is in an area of memory, we don't know whether it was mapped off disk. We don't know whether it was... Oh, actually, hang on. Yeah, we don't know whether it was off disk or not, right? What if I'm non-binary? Well, I've covered you as well. So what I'm thinking is this thread preamble, which is a function inside... Where is it? Whichever source common thread. That'll be in metserv. So this is inside metserv. Or maybe it's not. Oh, it's in common. Yeah, of course, it's in common. So it's included in metserv and referenced everywhere else. So thread preamble can exist somewhere in memory that's actually been virtual locked. And this is why this is a problem. So instead of thread preamble, we want to do something else. I'm just going to leave that there so that we know what it was before. Now, what we need to be able to do is we need to be able to say, I want the thread to kick off at a known location. And that known location must be in an area of memory that was mapped with memimage. So whether it's in the original .exe or somewhere else. Now, the way I'm thinking right now is what we should do is try and get access to a function that we know is always going to exist inside a Windows process. So when a Windows process kicks off, what are the libraries that it pretty much always depends on? So my thought process is this. If we call get module handle, I'll call get module handle A because I'm just going to do the ASCII version. I'm going to go give us a reference to kernel 32 because kernel 32 should exist in every process, right? So 32, I'm pretty sure it returns a handle, doesn't it? H module. Whoops. They're defined as the same thing behind the scenes, but we'll be more specific. Okay, so we've got a reference to a module, and now what we want is we want to point it to a function in kernel 32. In fact, we don't even need to do that. We don't even need to do that, do we? What if we did this? Create. Where does create thread live? Can we do this? Oops. Could we simply do this? So that's an LP thread start routine. Start routine. Can we do that? And instead of calling thread preamble, we pass in create thread. But we actually do it suspended. And then as soon as we come out, we call get thread context and we set EIP to, what type is EIP? It's a D word. We know this is 32-bit only, so D word is okay. Well, let's cast thread preamble. Can everyone see what I'm getting at here, right? So we're going to point create thread. We're going to pass in create thread as a pointer. Right? We're going to call the creation of, we're going to call create thread, and the thing that we want it to invoke is create thread. But we're doing it suspended. So create thread won't actually get invoked. Instead, hang on, what do we got here? By the way, ignore all these SSL errors. Something has going on with the Python extension source code and it doesn't build locally anymore. Ooh, what happened here? Right, so we need to, I don't know whether we can cast it or not. Oops. So that's going to do the same thing. All I want to do is figure out a pointer to a function that we know already exists in the process, right? And create thread, we know, is already mapped somewhere. I guess the question that we've got, though, we may actually have to use the get proc address option here. Because maybe referencing create thread here will reference the like local imports rather than the remote imports, and that could actually be mapped to the wrong area memory too. So how about we do this? Let's call get proc address. The module that we're going to give it is get module handle A. I'm going to point kernel 32. What's a function in kernel 32 that everyone loves? Load library. So we won't use create thread. We'll go load lib. Anyway, the function name effectively doesn't matter. We just want to make sure that the address that we are passing into create thread is something legit. And if that's the case, then technically we should be able to do exactly this. Create it suspended. Modify EIP. Now, actually, we've modified EIP here, but we've got to set the thread context back. So we need to go set thread context. Thread handle. Thread context. Oops. Thread context. Now what's going on here? Far proc. Okay, so we need to cast it. There we go. Is this making sense? Is everyone understanding what we're doing? Now the thing about this is that in my head, this makes perfect sense. And I'm kind of hoping it's just going to work. But as we know, that doesn't always happen. Oh, what have I done? I should terminate my my lines. Right, while that's doing its thing, let's just exit out of these. Now, code, Metasploit framework. Now we need to go into Data Meterpreter. Now, what is it that we've modified? We've modified Metserve here, okay? And it's only the 32-bit version for now. Now, I'm not seeing any comments, so I'm just going to keep talking. Please sing out if there are any questions. Now, for development, all we need to be able to do is copy the file that we know has changed over to here. Now, I'm pretty sure it's Metserve that's got the thread-related stuff in it, so I'm just going to copy Metserve over. And I've got that in code Metasploit payloads. Where is it? C output x86. Okay, so they're all the new ones, right? Let's just make sure that they are. It thinks that it's root because that's just mapped from the VM, so I don't think I'm doing silly shenanigans as root. Okay, so you can see an old one sitting there for Python because, as we know, Python's not currently building. But common, which contains all the shenanigans that we need, and Metserve. Metserve, that one there is the one that we want. So I'm going to copy that to Metserve x86 locally. I should add current folder. Okay, so this means that if we run a Meterpreter session now, let's just minimize all of these. Now we shouldn't see any injected threads here. I'm going to run this payload. Now payload.exe is staged, which means that when it connects back, Metasploit's going to hand over Metserve straight away. Okay? Which means we should get the new one. So there you go. Get injected thread returned nothing. Let's see if this crashes horribly. Ooh, something's not right. What have we done? Is it still running? Yep, still running. Did I just type something wrong? Yeah, see, we've already busted something, right? Because none of these things are working. So behind the scenes, I would say something's kind of locked. Something's not happy. Maybe we actually killed the primary thread somehow. So what we're going to do is I'm going to terminate this and do what I should have done before, just, you know, kind of hoping that everything was going to work fine. Was the thread ever resumed? Well, it gets resumed after the fact, so yes, it should. Hello, Usisavich. Man, that's a tough name to pronounce. Thank you for following and for joining in the discussion. I'm assuming set thread context is going to give us a boolean as well. Yep. Okay, so I'm going to do a quick build like so. Let's go dprintf. I'm just going to say get succeeded. I'm just going to pipe this information in here so that we can see. EIP is, and we'll give it, we'll just pass in a %p and we'll give it thread context dot EIP. We'll also do another debug print over here, because maybe loadlib is coming through. Yes, thank you. I've already been made aware of that. I'm sorry. It's just that I'm midstream, so I won't fix it while everyone's sitting here watching. But I promise I will fix it. But thank you for the heads up. Load library A is located at %p. See what happens there. Yeah, cheers. Thanks for that. I do appreciate you letting me know. Right, so what I need to do is, unfortunately, I need to go and change this line here. And what I might do as well, to make sure that I am keeping this consistent, should terminate my messages. Okay, so I'll just put a little message here as well saying set thread context failed, so that we know if it died or not. But what I'm particularly interested in here is creating the thread suspended, and obviously making sure that it works. And if it does, then we get the thread context out and check to make sure that EIP is pointing to something sane. And we'll go from there. Now, actually, is load library part of kernel 32? And here's an important point. Like, I'm on Windows 10. Did they move load library to a different DLL? Kernel 32 load library A Windows 10. Is this where I'm coming unstuck? Return value. It is in kernel 32. So this should just work, right? It should just work. Maybe there's some kind of proxying or something similar. But let's see. So I'm gonna rebuild this. It's gonna take a little bit of time because I've modified common.h, which means all of the things need to be rebuilt, but it shouldn't take too long. But while that's rebuilding, just quick recap. What we're trying to do is find a function that lives somewhere in the code section of a library that we know is probably going to exist already, which is why we're referencing kernel 32, as you can see here. In fact, what I should do, let's just go to options, come down here to text editor, all languages, line numbers. Now we can see line numbers. That's a bit more helpful when I'm referring to lines. So on line 231, we are trying to get a pointer to the load library A function, which should be there in every single Windows process, particularly when we are running at this level. And that should return a pointer to an area of memory that's readable and executable, and hopefully mapped from disk. Otherwise, we're in trouble. So let's just copy this over again. Make sure we've got the latest version. And it should only be metserv that's different, right? Okay. Make sure that that's the only thing that didn't build. Yep, that's fine. Macro definition. Is everyone playing along? Does that make sense? I've just I've done something silly. See, it's effectively dead. I need to run debug view. I'm going to run it as admin because there, why not? It's like running Ghidra. Let's see what happens here. Now we should hopefully see. Oh, here we go. Load library is located. Get thread context succeeded EIP is 0. Set thread context failed. Now, why would that be? We're going to have to do the get last error thing, aren't we? So according to the documentation, set thread context. So, Do not try to set the context for a running thread. Results are unpredictable. Use suspend thread to suspend the thread before calling set thread context. This function sets the thread context based on the value of the context flag's member of the context structure. Okay, so herein lies the problem. Check this out. So when we call a 64-bit app can set the context of WoW64 using WoW64. We don't need to worry about that because we're going to be in the same architecture, at least at this point. Maybe when we're doing cross-process injection, we do actually have to worry about that. Pseudo Gidra, exactly. YOLO. All right, so when we call get thread context, clearly what we need to do is set thread context.context flags to something, basically to say this is the context that we want to get out. Okay, so let's quickly re-reference the documentation. We have another follower. Thank you for following. I really appreciate that. Okay, so pointer of context structure. So let's go back over to this and look at the context flags. Context flags would be nice, but clearly this isn't giving us much at all. Context flags. Let's see if a thread context flags. Come on, show me where. Here we go. How do I use get thread context? Context all. Okay, well maybe I don't want context all. We only need one thing, right? Whoops. Let's minimize this, and instead we'll go context flags equals context underscore. What do we got? Context. Is there something in here where we can just say give us the registers? No, maybe not. Let's go to the definition of this. See what we've got. Control IP. Okay, so that's got the code segment IP in it. So what we need is context control. We don't need any of the other registers. All we care about really is context control. So let's use context control. And we'll set EIP, and then, well, yeah, okay, that should be it. Does that make sense? So we didn't actually specify any context flags, so no context was coming out, and then we were calling set thread context returns non-zero on success, but you're checking as non-zero as a failure. It returns Boolean. Oh, yeah, you're right. Thank you. I'm an idiot. If not set thread, oops. If not set thread context. Thank you. That was pretty dumb, hey? See, I do dumb stuff all the time. It's important that I have people like you guys around to stop me doing dumb stuff. Wow, there's 61 people watching. I'm blown away by that. I am a noob. I agree, Zarubis. Must be less newbie. I just caught a glimpse of myself in the corner of my eye where I got my laptop running with the green screen. I can see my own stream on the laptop, and it just seems funny looking at a stream of myself pretending to be in Norway with the Aurora Borealis. Those lights glorious. They like stunning. I'd love to go there one day. Okay, let's try this again. Sorry about this. Okay, kick off a new payload. Let's clear that up. Ooh, get thread context succeeded. Okay, so we did actually get load library from the right spot. EIP was pointed somewhere else. Yeah, so 77B0, that's really interesting. I wonder what, we should look at like memory map locations or something. But let's see what happens. Session died, so that's not good. Maybe what I should do, just to make sure that I'm not doing anything really stupid, is just copy everything over. which may not actually do anything. By the looks of it, it's still not happy. But what we've noticed here, right, is executing in thread, call negotiative encryption. Okay, so we are, that's right, we do everything in a separate thread. Every single command actually gets invoked in a separate thread. So if you happen to run get injected thread at a time where a command's actually being invoked, then you will actually see it there too. So, get thread context succeeded. Now this is fascinating to me. Why is EIP 77B0CE30? I would have expected that thread context EIP should be somewhere else. Why is that the case? Because when we created the thread context, we pointed it. Oh, we did point it at load lib, didn't we? Okay, EIP is setting to I'm just gonna go dword pointer thread preamble. Yeah, okay, that's something's not quite right though. Load library is so if load library A is located at this location, then once we've created the thread and it's ready to kick off, then EIP should match this location, right? What are you programming now? So what we're actually doing right now, mate, is we are trying to make it so that every time we create a thread from an injected process, that thread looks like it's not actually injected. That it is actually instead a legitimate thread that was created as part of the original process, so that attempts to determine whether a thread is injected or not result in it coming back false. That's the goal of the stream as it currently stands. So, but for some reason, and I don't know what it is, for some reason, we're not winning. Any ideas as to why this would be the case? I would have expected load library A, the location of load library A, to have been the same as EIP when it comes out. It's as if that for some reason there is some code that has actually been executed despite the fact that we've started it suspended. I would blame the stack. It's always the stack. It's like it's lupus. I think you might be right. Yeah, I guess if we're trying to pass parameters in, then on 32-bit, we are, I mean, what are we passing in? The thread context is this thread. So maybe what we need to do is actually like figure out where ESP is pointing to for that particular thread, and then write some information to it. That would make sense, wouldn't it? The interesting point, though, is that so we've got two. I've just thought of another thing we're probably going to have to worry about. I'll come to that in just a second, but we don't really care about this result. What we will need to worry about is exiting the thread. So here I'm thinking if we are actually mucking, if the stack for some reason isn't as we want the stack to be, so that the arguments that we're giving it are incorrect, let's put a debug message in here. just lost about 10 viewers. I must have said something really boring. Okay, thread preamble is executing. Thread context is %p, and let's do that, the thread pointer there. So, and then before we kick it off, we should also document this setting to blah. Oops. Creating thread at this point with context at %p. So let's put thread there as well. Okay. Do you do mostly Windows stuff? I'm messing around with packed elf binary at the moment. It's kind of hard to say whether or not we're doing. I do mostly Windows. I mean, with this kind of rat development, yeah, it's mostly Windows. But a lot of stuff I've done in the past is like CTF style challenges on Linux platforms. So there is a bit of elf shenanigans that goes on as well. If you have ideas for stuff that we can muck around with, then yeah, say the word. And we'll have a play with that too. What's going on here? No, I don't care about any of that. They did actually build, so... Let's just make sure that the timestamps are all recent. Yep, they're all fine. Copy those over. Okay, let's try again, shall we? Let's close this off. Okay, so pointer to the context. Create a command process thread, blah. Thread preamble is executing, thread context is null. Well, that's not good. That is a little bit concerning. So clearly we've got an issue where the stack is not as we would expect it to be, as per who said it, serializing me. Yeah, it's always the stack. I absolutely agree, man. The stack is always the problem, hey. But it is what it is, right? So what are we going to do? Are we actually going to muck with the stack as well? What do you think we should do? Any ideas? Any ideas? No? Yes? I'm thinking what we should do. Attach a debugger to the payload and break. Yeah, I think so. I think that's a good idea. No, I think I'll set a hard-coded breakpoint at all of the things. So, what we're going to do? Where should we set? Well, I know we're going to have to set one here. Let's set one here. And we'll go... Is it int 3? It's int 3, isn't it? I guess I could also go debug break. That's probably the better way of doing it. So let's debug break there. And we'll actually do the same thing. Actually, what I'm going to do first is get an idea of what the stack should look like legitimately and then see how far off. Death Pimps, how you going, mate? You played a little bit with the Ghidra already. Any chance of a stream? Yeah, man. I have played with it a little bit, and I was kind of assuming that a bunch of people were going to live stream playing with it. But you know, if there's enough interest, I'm certainly happy to do it too. If everyone's keen and it gets enough upvotes, then we can fire up Ghidra on another stream and have a bit of a play with it. So certainly open to doing that. Could the context not be open enough for when it changes the preamble instead of just control? Well, that's the thing. Like, I think it's as if there is something kind of quirky going on that shouldn't be going on. So what I'm going to do is I'm going to just comment this stuff out here, right? Let's comment this out. And then up here, instead of creating the thread like we were, let's go back to creating it with thread, what was it again? Preamble. All right, I'm going to build that and copy that over. Man, so many followers tonight. Thank you so much. I had a pretty consistent sort of 55 or so people attending and pitching in, which is lovely as well. So I'm very grateful for that. Oh, that's not what I wanted to do. So when that's finished building, which it has now, we'll copy that over and go back over. For those people wondering, I am using VMware and flicking between VMs, which is why you're seeing what you're seeing. Right, so now what I need to do is kick this off inside. I'm going to use WinDBG, by the way. Open executable, desktop, payload, go. Righto. So, where do we get to? Clearly it's, I'm waiting for it to, here we go. Kernel-based debug break. Righto, so this would be inside, I would assume, here. Disable thread error reporting. So before we continue, what I'm interested in is the stack. Because I think we're effectively going to have to replicate this. Alright, so let's take a copy of that. Because this is going to work fine, right? There you go, there's another breakpoint. These are all threads being created and killed because of the commands that are coming in. Okay. Alright, so let's stop debugging. Debug. Debug. Stop. So, at the time that was invoked... Oh man, I lost on my output. What an idiot. Okay, let me just quickly run that again. My bad. So what I'm interested in getting to is at this point we can see here. Thread handle. Preamble is executing. Okay, let's take a copy of this. So this is in the main thread. We can see that the thread context is here. Load library is there. We don't care about that. We're going to pass in this as a thread context. Thread preamble is executing, and that's where we've got at this point. So we just want to step out of this function. Okay, so that right there is calling disable thread error reporting. So we can see it's in a similar memory region here. So this is what the stack currently looks like leading up to that. Actually, I might take a little bit more just to be clear. Because remember before we actually saw a bunch of zeros. So let's just drop this in Notepad. So there's a pointer to something. That's the thread context on the stack, which is kind of interesting, isn't it? I would have expected. Oh no, that does make sense. Okay, so I would assume then that when we see the break, as we're about to call, that maybe these puppies here are actually off the stack by the time that we get there. Could the context be open enough? Yeah, I don't know what you meant by that, Atwolf, to be honest. Hey, OJ, first time catching you. Hey! Thanks for joining in. I assume that you've had the pain of watching my streams archived. I'm stoked that you're here to watch as well. I don't know how to pronounce your name. Is it Morvi? Let's go with Morvi, and you can correct me if that's not right. So, but yeah, as Zorkat is saying, what we're trying to do is just trying to make our creation of arbitrary threads inside Meterpreter a bit more silent, so that Jared Atkinson's get injected thread is unable to detect what we're doing, which is complicating things just a little bit. It's a little bit harder than I was expecting, but that's a good thing, right? So I'm going to stop debugging there. Now let's go back and do what we were doing the second time. Excuse me, and we'll compare these results. Okay. Loving the green screen? Yeah, it is. It's the very first live stream with the green screen. As I mentioned at the start of the stream, this was off the back of the OPSEC concerns that were raised during Justin Stevens' most recent live stream, where there were people trying to dox as a result of things going on in the background, and that's generally not cool. And even though I think most viewers wouldn't bother chasing those things up, I think I just wanted to tighten things up just a little bit. So yeah, that's why it looks like I'm in Norway at the moment, and I will move around the world as time progresses. Okay, that's looking good. Copy that over. Go back to WinDBG. Oops. And let's see what happens this time. Okay. Hopefully you guys can all see this. Now check out this. Look how far away all of this nonsense is. Like, we are clearly a very, very long way away from where we need to be. Let's look a bit further. Yeah, stack is well and truly balked, isn't it? And it's a long way from anything. So what we might need to do is give it a fake stack. We might just need to give it a fake stack. Is it worth doing that? Giving it a fake stack? Problem with trying to solve these problems in a generic sense is that there are lots of cases where things like this happen. I wonder if it's because of the function that we've chosen. I would have assumed, though, that creating the thread suspended wouldn't have done any of this. That's the thing I'm a little bit confused about, is why is the stack so destroyed? What is so fundamentally different about what we're doing here? Any ideas? Because we're creating them both suspended. I'm confused. I wonder what's going on. I'm keen to hear any ideas as to why the stack may actually be balked. Okay, I think what we're going to have to do is just create a fake stack. I think we should just create a fake stack and terminate the thread once the stack has been... Actually, if we create the thread, if we do that, then we aren't going to be able to... What I'd like to be able to do is create a fake stack frame, area memory for the stack somewhere else, and have it sort of all self-managed. Clearly that isn't going to be the case. Maybe, you know what I'm going to do? I'm going to change this to context all. And let's just see if that makes a difference. I don't really think it will, but you know, we'll see. Because that's going to give us at least ESP, right? Maybe we can... EIP is blah. I'm going to put ESP in here as well. ESP is... thread context dot ESP. Now I'm going to go back to the previous version because I just want to see what ESP looks like. Maybe I should choose a function that's not so common in kernel 32, one that wouldn't necessarily be invoked, and then set a breakpoint on the kernel 32 function. And then check to see if that actually gets called prior to our existing breakpoint. Does that make sense? Jonathan Frakes is now following. Thank you, Jonathan. Yeah. I'm going to do that. Let's just do that. Let's do a little bit more debugging. Make sure that what we think we're doing, we are actually doing. Wolf, what's that, mate? I'm going to open that up. Understanding and evading get injected. There you go. I told you someone's probably already done this before. Blog.xpns. Okay, so xpn's done something similar in the past. Be interesting to see whether the approach that they're taking is similar to what I'm doing here, and whether or not it's being solved in a general context. All right, hang on. Let me open it up. Let's have a look. Sorry. Don't know why copy and paste isn't working. I blame my VM shenanigans. HTTPS. What is going on? HTTPS. blog.xpnsec.com. Understanding and evading get injected thread. Yep, XPN. This dude's rather prolific. Looks like he's pretty much doing exactly what we're doing. Yep, analyzing the same pieces of code. Second interesting call virtual query. Injecting DLL via load library. Load library as an entry point by doing this okay. Bypass the following check. Okay, so it is pretty much doing exactly what we're looking to do. That's hilarious. Open process, virtual alloc, get proc address. Oh, that's interesting. Get current directory. Okay, I see what. Okay, so this is actually calling load library on a new DLL that you've written to disk. So that's not the same thing. You can successfully. This is of course obvious weakness to this technique, and then we need to drop a DLL on disk. Yep. So set. Okay, set thread context. We now know a good way to stay under the radar is memory image, but if we update the entry point of our thread just before starting, this would be enough to evade detection. In this example, we will look to leverage set thread context to redirect execution to inject shellcode. Allocate memory, copy our shellcode, spawn a suspended thread, retrieve the current registers, update RIP. Okay, so he's using 64-bit. Yes, we do not want to write to disk, so I don't think this is what's going on here. In theory, it's our thread's base address. Yeah. So what is he doing? He's got some shellcode. Don't know what that shellcode's doing. Maybe that's just the message box shellcode or something. Open the process, allocate memory, get a pointer to load library. Ah, yeah, okay, right. Okay, so he's getting a reference to message box A and poking that into his shellcode. So obviously that's the message box shellcode. Writing that to somewhere. Creating remote thread and passing in the pointer to load library. Right, and then he's doing exactly what we're doing. He used context control as well. RIP register set to blah. Updating RIP to point to our shellcode. He's doing exactly the same as what we're doing. I think the reason why it's probably not a problem in this particular case is because we're creating a thread just points to this shellcode and doesn't rely on the stack being legit. Yeah, right. So this is one in the left outer field. Okay, so he's going to use a different method. I'm going to stick to what we're currently doing though. I just think like clearly the stack is balked. So what we need to do is create a set ESP to something that is reasonable. But what I'm confused about is why ESP is actually as bad as it is. So let's restart. Okay, so we can see here ESP points to oops. Let's put this down here and we'll leave all that other stuff alone. So bailing out. Let's just see what this says about the stack. Usage stack, base address, end address, region size, mem commit, read write private. Okay, so that seems legit, as we would expect, and there's plenty going on. Although there is one thing that's interesting about this. Yeah. So ESI is the thread. So ESI at this point contains a pointer to the thread context, yeah? Push ESI, call ESI. Yeah, right. Yep, so ESI was this. Oops. That'd be why this looks strange. There, that's better. Yep. and the thread context. So we push ESI and then invoke whatever function, which was the thread preamble. Sorry, not thread preamble. Yeah, whatever it was that we'd given it. Okay. Yep, that makes perfect sense to me. So, sorry, I didn't hit enter my following that link. Point was that it's similar to what's being attempted and is using control context should be in theory. Yeah. Yeah, so it's I think it's working in that context because the shell code that's being invoked doesn't give a shit about having a valid stack. So let's see what happens here when I reverse these again. Try and get a better idea of what's going on. Funny thing is, like, in principle, this seems like we're doing entirely reasonable stuff. What I don't understand is the difference between when the thread is suspended and where the breakpoint actually happens, how the stack can be so wildly different. That's the thing I think that's baking my noodle right now. Let's copy that over and restart. Okay, so load library A. ESP is 0 to 3. Okay, so that's still fine. EIP is ESP -4. Now, is there anything in here that looks like it's in any way near where we need to be? We can see it is a new... Aha. Okay, I think I can see what's starting to happen here. ESP is thread context 0707. There's nothing in here that resembles that thread context that we want, hey? Sorry, when I say thread context, I'm referring to it in the Meterpreter sense. Yeah, so that... Oh, clearly that's going to be poked. So, this is the address that we're expecting to see somewhere in here, and it's just not there at all. I can't see it. Okay, so that, I think to solve this problem, can you search memory for it? You know, I don't think I need to search memory for it. I think we can just shove it in there. So we know that ESP at this point, at the point, see, we're about to call push ESI. What's ESI? ESI is 0. That's our problem. You like turtles? Excellent. We all like turtles. Now this is a concern because it's as if, like, for some reason ESI is set to 0 at this point. And that would be because... Let's just figure out what's going on. Inside our thread preamble, what's the function ESI? Oh, that's this bit here. See how we've got disable thread error reporting followed by thread func. So debug break is what's basically given us that line there is the debug break call, followed by an immediate call to disable thread error reporting, which is that line there, and then straight away we're going push ESI and and calling, we're basically dereferencing null at that point. So the technique used by this lock pos seems interesting. It exports functions, but instead of calling them directly, it maps those functions to a virtual address space, so it kind of keeps a clean copy of that. Yeah, right, that's interesting. That is interesting. We should dive into that later down the track. Maps them into a... Yeah, that's nifty. Stale Breadly. Can anyone explain the current objective? Yeah, we've done that a few times, buddy, but long and short of it is we're just trying to make threads look like they haven't been injected into the process, but actually look legit. Thanks, Zorcat, for passing that on. So our problem here is that this register, this ESI register, is null at the time of writing, and that's the problem. And I think the reason for that is because maybe the function that we are invoking mucks with ESI, right? So if we go address kernel 32 bang, is it load library, eh? Kernel 32 load library. Where is kernel 32? Kernel 32. Hang on. Address kernel base. Okay, there we go. Base address. Mem commit mem. There you go. So we can see that mem image flag has been set on this area of memory, which is exactly what we want. Let's just set a breakpoint there. Okay. Let's clear that. And we'll go, is it UF? Oh, I should have just given it by name. I want to see the start. Is there anything that mucks with ESI? Yeah, there's nothing here that says that should have somehow caused ESI to fail. And I don't necessarily like the idea of... yeah, so ESI is supposed to contain the thread context at this point. Stale Bradley, gotcha, sorry. No, that's fine, man. No problem. It's important that you have the same context as us. Thing is, I'm concerned that poking a value into ESI at this point would not do what I really want it to do. We're making the assumption that if we poke a value into ESI at this point, that future implementations of this isn't going to have the thread context in that register or in the on the stack or something like that. So I mean, what we can do quite easily here is go thread context.esi is that. But that worries me. Not going to lie, that worries me. Should we test it? Well, let's test it at least. But we're making an assumption here that when we compile this code, that the thread context, the ESI register should have a pointer to the thread object that we're interacting with. But I really don't like that idea. That worries me. My feeling is that when we do this, it's probably going to work though. Suspending. Okay. see what happens. Everyone's still with me? I've got 56 people still watching, so I'll take that as a mini yes. Okay, so ESI, look at that, ESI is 0. Why is it 0? Did I copy this over? I did copy it over, didn't I? I'm confused. ESI is 0. Why is it 0? What the fuck? Yeah, exactly. Are we trying to pwn some kernel driver here? No, we're not. We're playing in user land only. We're not mucking with kernel stuff at this point. We're just trying to evade some very simple detection mechanism. And I'm really interested to know why, even though we've just set ESI. Let me just make sure that it compiled properly. I can't see any errors in here. So set thread context worked. Am I setting it to the right thing? Let's have a look at what ESI is prior to it. What's at EBP? See, the thing is, the stack frame itself is legit. It's the contents of the stack that's the problem. But ESI, because if we have a look here, it's ESI and EDI that are wrong. They've been cleared. Thread preamble is the hook function that we use to make sure that we disable the error reporting before we pass off the call to the target. ESI is set from EBP though through above, is it? Where? Prior to this. Push EBP, push ESI. I'm not seeing any pop into ESI. Oh, from here, yep. Yeah, right, okay. That is, I tell you what, that is much better. This thing here, EBP plus 8. So EBP, here we go. Thank you, who is that? Morvi. Thank you, Morvi. So I was lost on the fact that it was ESI, and that's not what we want to do, right? Let's go back to ESP, because what we actually want to do is we want to get EBP plus 8. Okay, so we can do this quite easily. Once we've got our thread context, then we can say thread context context.ebp. Jeez, I can't type. EBP plus 8, right? That's the memory region that we want to read from, or I should say write to. So I'm going to cast that to a, we're doing this in 32-bit land at the moment. I'm just going to cast that to a D-word pointer, right? And then I'm going to dereference it and set that to the thread handle. Pro developer, hey buddy, thanks for the stream. Been lurking, logged out for a while. Just thought I'd jump in and say throwing a breakpoint inside of the function around the get set context calls might get better. Yeah, you're dead right. That may well actually be handy, but I actually think that we've nailed the problem based on what Morvi's just pointed out. Again, this is me glossing over the important detail. But yes, the problem is that we didn't actually, our thread context handle in Meterpreter land wasn't written on the stack for some reason. So I will answer your question in just a second, Atwolf. Okay, so a D word is always 32-bit. Okay? A D word star, which is actually a pointer to a D word, is 32-bit on a 32-bit system, and a and is 64-bit on a 64-bit system. A D-word pointer is a define for an integer value, an unsigned integer value that matches the architecture. Okay, so a pointer to something and an integer value of something are not the same thing. So they are effectively the same size. So D-word pointer, D-word underscore PTR would be the same size as D-word star. It's just that one's a pointer and one's an integer type, an unsigned integer type. Does that answer your question? You use D-word pointer to abstract architecture size in certain contexts, but in this case we can't actually do that. We'll have to do it differently with 64-bit, but I think once this is working, we should be able to move on just fine. Let's see what happens. Thanks for everyone sticking with me. I've still got nearly 60 people watching this nonsense, which is very exciting. Yeah, I'm kind of digging this background music too. This is a Monster Cat Gold subscription, so thankfully, or slash hopefully, I'm not going to get any ridiculous takedown requests because of the music. Okay, here we go. Let's see if we can get some sense out of this thing. There you go, look at that. Oh no, that's not right. What on earth just happened? So here we got a crash instead. Ah, is this because... Yeah, we're breaking at the point where we're trying to write. I'm doing something wrong. EAX plus 8 and EAX is 0. Is that because... Oh no. Well, let's have a look at what EBP is pointing to. Something's telling me that I'm doing something silly here. So thread context EBP, that's a D word. And I'm casting that to a pointer. I'm effectively trying to write. I think this is the instruction here that's failing. Right? I'm actually trying to write to that area of memory. Play some Prodigy in the background. Attribute Keith. Yeah. Amen. Can't believe that dude's gone. Hey, that's just epic. Kind of hoping this was going to be a little smoother. Is what it is, though. That's the nature of these things, isn't it? All right, back we go. WinDBG. Let's restart that. What we're failing at right now is this write instruction here. So we should be able to see what EBP should be set to. Okay, so thread context EBP is null. What? You've got to be kidding me. Maybe I should be looking at ESP at this point. I wonder why. I wonder why EBP is blank. I'm asking for all of the context. You print it before you set it. No, I'm getting that out of the thread context. So if you see here, we get the thread context. We're asking for all of it, and EBP is 0. Is there some documentation that implies why that would be the case? So that is not the thread security and access rights. Handler thread is context to be set. Handlers have set access right. That does answer the question, though. Maybe what we need to do is look at what ESP is and go from there. That might well be it. If that makes sense. Yeah, that would most likely be the case, hey? Alright. Let's go back to ESP. So I'm going to log what ESP is. And then once we've set the thread context, we're going to see what ESP is and how different it is to EBP, and we can do some math based on that. Okay? I do feel like this is like pretty specific to this like implementation, but there's probably not a lot that we can do about it at this point, as I'm not really sure why the stack is so munged. That is what it is. I mean, the point here is a thought exercise, and hopefully we're all learning something from the process. Okay, so we've hit our breakpoint at least. Whoops. Righto, so ESP is 241FF0. EBP is FFEC. So there is only 4 bytes different, right? So it is ESP minus 4. Is that correct? No, it's, sorry, ESP plus 4. At the time that we've actually got this. Okay, so EBP plus 4. We have another subscriber, Duzcum. Thank you for, sorry, not subscriber, follower. Thank you for following. Righto, so yeah, I get the feeling that this is... actually, hang on just a minute. So we are referencing inside here, we're referencing ESI is whatever's in EBP plus 8. So EBP plus 8 is FF4. Which, and ESP at the time is 4 bytes less. Yeah, okay. So with EBP plus 8, FF4, 241 FFF4. And here we've got 241 FFF0. So we need to take that, add 4 to ESP. Yeah, which is basically what I had. ESP plus 4 and poke it in there. And hopefully we won't get a write access violation. Would it make sense to go back to basics? Start without any changes, debug it and see what works, and then try to replicate with the EIP thread start address change. At this point, the only thing that we would be trying to understand is why pointing the thread start pointer somewhere else, why is it that the context around it is so different? Is anyone else having the comments on screen crystal clear but the code somewhat blurred? I hope that's not the case. Do I need to like make the code a little bit bigger? Is that part of the problem? How about this? I'll make it just a little bit bigger and we'll go from there. Hopefully that'll be beneficial. Same issue, looks fine. It could be, yeah, you might need to change the streaming res, but I've just made it a little bit bigger anyway. All right. Much better now? Okay, cool. Okay, what do we got in ESP and EBP now? ESI has a value. That's a good sign. I don't know whether it's correct. Let's have a look. 5C75F0. 5C75F0. Ooh, something broke. I wonder why that is. EAX is 0, EBX is 0, EBP is 0, ESI, EDI. This is pretty cool. Looks fine to me too, but I've got screen maximized. Okay. Okay, so command processing finish, returning true. Ah, returning true. I know what's going on. Does anyone else know what's going on? Because I know what's going on. Why is it crashing? When it closes the thread. Yes, that's exactly what it is. Because this, remember, is bailing. It's basically going to exit at this point and then return. But we don't have all of the thread-related shenanigans in place. So exit thread exits the current thread. We're just going to call exit thread 0 here instead and force the thread to exit. It's dirty, isn't it? I did indeed create the thread with the proper access rights. Otherwise, we wouldn't have been able to set the thread context in the first place. It's interesting that EBP starts at 0, but actually makes a lot of sense. See what happens now. Okay, that's okay. That's okay. That's okay. Ooh. All right, let's get rid of this debug break. It's such a filthy hack, isn't it, hey? Can you go back to just using the context control now instead of... Yes. Actually, no. Because I rely on ESP, I think ESP doesn't... Actually, does it? Oh, I should go back to the source, shouldn't I? There's plenty of information here about it. Context control, stack pointer, base pointer. Thank you. I'm confident this is going to work now. It's 10:15. All right, let's do the YOLO thing. And let's see if the session actually works. I'm not even going to run it in a debugger. Boom. So that's interesting, isn't it? So if we type shell now, everything seems to be working as expected. What does get injected thread say? Hey! Boom! That's cool. Woot! Yay! Okay, so there are a bunch of assumptions, obviously, in that, but I think that's pretty cool. There's something in that I think that's worth exploring a bit further, and obviously that kind of thing in 64-bit land will be a little bit different. Boned! Yeah, I'm happy with that. So that's a nifty little bypass. I think it is probably worth exploring the reasons behind why pointing at loadlib, for example, has such a different sort of stack-related context. It's as if it isn't suspended initially, right? 32-bit messy code for the. Should we do 64-bit while we're here? I'm happy to do 64-bit. You want to do 64-bit? Yeah, go on then. Let's get 64-bit out of the way while we're at it. Okay, so if def win 64 else righto. Let's go RSP. Okay, now we're not going to be dealing with the stack here, are we? Because we're going to be passing a parameter in via what would be the first one, right? It'd be RCX. Is it RCX on Windows? So we want to set rip. And we don't need to do this. We need to just go... I'm pretty sure it's RCX. RDI? You sure? I thought that was Linux. You might be right, though. Should go and read some documentation on that, shouldn't I? So that means I can't just use context control. Because here, context AMD 64. I think I'm going to need to specify context all for this. Soda Mouse Prime, thank you for following, my friend. Let's check the documentation. Windows 64-bit assembly parameter passing. Context full as well as contains more useful options. Yeah, maybe it does. Calling convention, that's what I wanted. Calling conventions. A is in RCX. Nailed it. I know it's different in Linux, like RDI and RCI. RCI, RDI, I think are RSI, RDI. No, not at all, man. Like there's so many different calling conventions, so it's really not surprising. But this probably is gonna be a fair bit cleaner. Now we need to go x64 now. Copy the 64-bit version over. While that's happening, let's bomb out of this. And we'll do payload 64. Windows x64 Meterpreter. We'll put this on a different port so that we can have both listeners running. So we'll spin that up while that's happening. And then MSF console, run -j, set L port 4445, set payload, Windows x64 Meterpreter reverse. Oh, can't type. CCV. Run -j. Wait for that to kick up because you know Ruby's really fast. Okay, still only the Python stuff that's upset. Let's take another copy. Yeah, I do, but I change it all the time and shush. Payload 64. Now before I copy those 64-bit things over, let's just make sure that the thing actually works. shell. Can we see it? Yep. Copy. Now, should we YOLO this as well? Let's just see if it works. What could go wrong? Ah, it died. Of course it died. That's pretty funny. Actually, let's see where it gets to before it dies. Where's debug view? Get thread context exceeded. RSP is null. RIP. ESP is okay. I'm going to change that to all. Yeah, maybe. I'm just going to say all because I'm lazy. Setting to blah. It's interesting that it died. Oh, it definitely worked. Copy, lazy. Yep, I agree. Get thread context exceeded RSP. Okay, so it's probably died again. Okay, so RSP actually came out that time, but maybe this is actually, given that we're not using RSP, let's. Why am I doing that? Well, I blame you guys. So first of all, this needs to be dword pointer. That needs to be dword pointer. And we are just setting RCX. We're not trying to dereference it. Yes, that's correct, Pro Developer. I was casting to dword. I should actually be doing like this here as well, just for the sake of being sane. Because that should still do the same thing, but we are setting two different things, and that should be. Let's make sure that's. Build that again. Whoops. Build. Okay. Yeah, we were dereferencing RCX like we were with ESP and writing a value to memory, which is dumb because RCX is probably 0 and we're trying to write it. We actually just want to set RCX. So YOLO take 3. That's a bit better. Yeah. It works. Okay, let's see if we can. Boom! There we go. I love computers sometimes. That's a lot of fun. All right. So that's interesting. Hey, so nicely done. Thanks for playing along, everyone. That's pretty interesting. Hey, didn't get why in 32-bit you need ESP and in 64 just RCX. Okay, so Death Pimps. The answer to that is, let's go back to the documentation and I will show you. So in 32-bit land, every time you call a function, so let's see, and we'll ignore the whole standard decl thing. But what you do is when you call a function, you'll see here in 32-bit, we're pushing all the arguments onto the stack. So ESP is what's changing, and then when a function reads the arguments, it's actually going based off EBP and pulling arguments directly out of the stack. Whereas in 64-bit land, I wonder if there's a 64-bit. Here we go, 64-bit calling convention. You can see in 64-bit land, the first 4 parameters are passed in RCX, RDX, R8, and then R9, and then anything else after that is pushed onto the stack. So the first 4 parameters go via registers. So because we know that in 32-bit land we needed to take the value of the thread context and push that onto the stack, we went to RSP, we offset it from RSP, and then we wrote our thread context pointer to that area of memory that the ESP was pointing to. But in 64-bit land, we knew that we were just passing a pointer to our internal thread context, which is the first parameter, and we know that the first parameter in 64-bit gets passed in via RCX, at least when it's an integer or a pointer. If they're floating point, they're different registers. So that's basically how it works. The very first parameter that we were giving it goes in RCX on Windows. In Linux, I think it's RDI or RSI or something like that. So that's why we had to put it in there. Yeah, no worries. No worries at all, man. That's why we're here. So there we go. We have the means. We have the means to get past this get injected thread, which is kind of cool. I think what I'm going to do is I'm going to wrap it up at this point. We've been at it for nearly 2.5 hours, and I think that wraps up the idea behind what I was trying to do. I don't know whether this is ready for prime time. I don't know whether I would PR this to Metasploit just yet, but it's certainly worth pondering around. Thanks to the stream. I've been meaning to clone the repo and have a look at things since 5 changes. Yep, exactly. Have updated Kali for a week or so. Yeah, do it. Pro developer, definitely do it. There's any contributions to Metasploit will be very much welcomed. I'm sure I can speak on behalf of the entire Metasploit open source community and the maintainers and contributors and committers that any contributions are very much appreciated. So, by the way, how do you guys get stuff to fiddle with? If this sounds weird, I'm not quite sure what you mean, but feel free to elaborate a little bit more on that question. I saw exploits related to Django Wizard Driver. I've never heard of Django Wizard Driver, mate. Need to clean up the thread close before the PR and also test out other types of threads like migrations. Okay, so migration is the next big thing that I want to play with, because migration clearly is actually pushing stuff into another process. So like if we migrated right now, let's do that. Let's get our Explorer PID. PS-SEXPL. Nope. Yes. This could very much break stuff. So let's migrate to 5512. Hopefully it'll work without crashing. It could just die horribly. Could also be that there are other things stopping migration from working. Yeah, that's killed it, hey? Uh, 5512. Excuse me. Migration code is... see how that worked from 32-bit, but didn't work from 64. Isn't that interesting? Okay, so where did he get the driver? Don't know. It could have been installed from some other piece of software that he's been playing with. But yeah, I mean, it's just a matter of looking at what's been installed on your system. Righto, I bet if we call get injected thread now, we're going to see our main thread. There you go. See? Now, if I run shell, I probably will still only see one thread. Yeah, that's our main thread. It's a 64-bit process because it's on a 64-bit machine, but for some reason the migrating from 32 to 64 worked, but not 64 to 64, which is pretty interesting. Yeah, so Explorer is definitely 64-bit. and the process that we migrated from was definitely 32-bit. I should have proved that too. Oh, you can see it here. So that session that just came in was 32-bit, see? And now we are a 64-bit Meterpreter. So we went from 32 to 64 just fine. I'm not really sure why that's the case. Maybe there's another bug in migration that I need to try and fix. But yeah, so our main thread right now clearly is a problem. So what we need to do in our migration code when we call create thread is basically do exactly everything that we've done here, which means we're going to have to go and muck with migration stubs. But I think we should go ahead and do that another day. That would be interesting, and that will give you guys exposure to, one, how migration is implemented, two, where the migration stubs happen to be, and three, a couple of the issues that we're going to face when going from 32-bit to 64-bit. Because there's an edge case here which relies on transitioning from from a 32-bit thread to a 64-bit thread, and then resolving a function or doing a function call on wow CPU or something, a DL. So in other words, we're looking for kernel 32 and it doesn't exist. So we're going to have to muck around with that. So yeah, anyway. Yeah, that's a good idea. Just go and pull down anything from, or Major Geeks is one, File Hippo, CNET downloads, download.com. Like, there's so much software coming out of there all the time that's worth just installing and mucking around. So, yeah. Anyway, does anyone have any questions? Is everyone on board, understand exactly what's gone on? I sure hope so. But I had a bit of fun. I learned something. I hope you guys learned something too. And, you know, fingers crossed that, that you guys will join me for future streams. Yeah, thanks. Thanks to everyone for coming along. Went for coffee. No, Mugu, we didn't. We just basically poked value into memory and off we went. So have a quick look at the end of the stream when we're done. So, yep, thank you very much. Insolent, you were there too. Awesome. That running zombie is cool. Yeah, it is. It's the default one. So I think I'm going to leave him there. All right. I will sign off now. I'm going to leave you with, I've got a little scene ready to go. Say that we're ending. But much appreciated. Really appreciate your company. Really appreciate your support and your comments and the people who have helped me to make sure that I don't make more mistakes than I was already making. Yeah. Thank you. And until next time, take it easy.